Hi guys, I hope you're good since last video. Flask and Django APIs are easy to set up, but how can we do those in Rust? We are going to take our time in this video to explore that, and would see it in a Pythonic way, but try to mimic it in Rust. But it is more strict in Rust. Let's see what are the mandatory stuff, like for GET and POST requests. We see that local AIs are improving at a fast pace and that more truly open source models are being released. Expect in the future to have a plethora of choices, even to run those from your phone. You are not yet behind. Just tell to yourself, okay, this weekend I'm going to dive in until it works, until I get something running. The excitement will take you to the next step, but you need to do this first move. I left a link in the bio for students who want to learn AI by doing, beginner devs who want to think at a service they could offer, or business owners who want to use AI for themselves. It is free, amazing PDF guide to download on the video. Link is in the pinned comment and video description. Get it now from our hub, check our houses. Also, please like and subscribe. Thank you for your support. Let's get started. Okay, let's make the directory. So we're gonna call it Rust HTTP request. You can follow along with your terminal. So it's not gonna be like the videos that I don't like. Do like this, that, and boom, here's the result. Doesn't work like that. You're gonna get some errors. So we're gonna see those. So cargo init. We got a toml file. Let's just check what is in the toml file. And now we're gonna add our dependencies that we will need for this experiment. So cargo add Axum. There are different ways to do it. I've chosen Axum. Cargo add Serde. And we're gonna add the features, which is the derive feature. So not future, features with a S. And after we're gonna add also Tokyo. So the features here full. We'll be explaining along while coding what are those features. That's what we need for this tutorial. We go to the source folder and we're gonna work from here. There is a main.rs because we did the cargo init, and we got a print hello world inside. Should be hello Shibuya normally, but we're gonna change it and we're gonna be working on that later on. Okay, so now let's do, before coding anything, do all the imports and prepare the file. Do not get all those warnings coming because we're not using some different functions or codes, or some different part of the code won't be triggered because we are not calling those through the API. So we first allow dead code to limit warnings, as for example post requests. It won't be triggered every time, but we might get the warning in the console. Trying to get a clean console in order to understand what's going on, and when there's an error to just target and see the error straight away. And here we're gonna add this decorator, allow dead code. And now we do our imports. So we're going to start with a get request in a simple mode. And after we're going to slowly, incrementally go into the more complex stuff and explain how it works in Rust. So Axum is one of the dependencies that we have added. So there is Actix, there is Rocket, there's different ways to do that. So I'm going through Axum because I find it, I don't know, it talks to me. Looks like Flask or Django for me. HTTP, methods, get, post, delete, patch, and so on. So that's what we are going to use here by importing routing from Axum. And the routing has those methods, get and post. That's the only method that we're going to see here in this tutorial. I'm commenting out post method because I'm not going to use it for the first part of the tutorial, because it's going to be adding complexity to it. We're going to be going slowly, step by step. This would be like our urls.py in Django, like to get the routes. We have here a struct called the router. Help us to build those routes and to be able to handle different types. So tuple, string, whatever we want to render has a response to the HTTP request, even JSON. We can here import from Axum response, but the into response struct, which is going to be helping us to have more flexibility and be able to render any type that we need to render. We need this flexibility. But there's another dependencies after that I'm going to talk about that will help us for that. So to be able to use a JSON struct, which will help us with any custom struct that we're going to make later on. I'm going to here just import from Axum JSON. Can close those comments. So that was for Axum. And now that's the other dependency, Serde, which is going to be helping us serialize and deserialize those HTTP requests. So here I'm just going to comment this with Serde here to avoid errors, as we need to serialize. And deserialize. Okay. So we're going to be using later on some structs. Those structs need to be converted into a JSON format, for example. So we need to serialize and deserialize those. So when we're receiving an incoming post request, we need to serialize it. But I'll be explaining it later on. Struct to JSON. That's for Serde. So we're done with our imports. If I've forgotten any import, we're going to add it later on. But for the moment, that's what we need. We will do all in this main function. So I'm not going to use some side files and so on to make it easy to understand, also to manage. There's not a lot of code to write, so we're going to put everything into the main function because we just want to understand the architecture of it and how to structure our code to be able to make those HTTP requests, to receive those and to respond to those. Here we will use Tokyo because we love Japan, and accessory, the Tokyo dependency that we have installed helps as well to run asynchronous processes and accepts TCP connections. So we're gonna put async keyword in front of the main function. So it's gonna be asynchronous. And here we're gonna put the decorator Tokyo, and we're gonna call the main. Here we close. And now we can write our code inside. If we need any side functions as a helper, we're going to put it outside of the main function, and it's going to be called from the main function. But everything is going to stay in this main.rs. After, it's up to you to separate those in different files and to import those into the main.rs file. So first, let's define an address where our local server will be listening to. So this will be the address of the API. Let address. It's an str 127.0.0.1 on port 8001. We need to create a listener to be able to accept TCP connections. So the let address is just an address for the moment. There's nothing actionable on it. So now we need to create this actionable step. We could have imported at the top of the page, because you will see the way I'm going to write it. I could have included it in the import at the top of the page, but I'm just going to put it in the code because it talks to me. So because it talks to me better like that, so here I'm going to put it in the function. And you're going to understand why, because if I want to just read the code as if I was reading English or a story, this talks to me better. So let listener, we're going to define the listener. We use Tokyo net. So that's what I could have imported at the top. And we use the TCP listener struct. And the TCP listener struct has a bind function that we're going to use. Utility bind, and we're binding the address. So now the address is not just an str, it's something actionable through a TCP listener. And we use await keyword. You can rely to Python for that. Async await. We got our keywords. The function is an async function, and inside we're waiting for processes to happen. So here we're just going to use await like that. You might probably, if you look at the documentation or go through some other tutorials, see it written in a different way. Here first, I prefer to define the listener, and after to print server running at address, and I put the address. Okay, it will be able to print it, but if you don't want to bother, just put the debugger everywhere. So you put into the parenthesis, into the curly braces, colon, question mark. I think I'll be doing that because I don't want to be debugging those stuffs. I want to just focus into the tutorial, which is about making those TCP calls. Just for the video to not be very long. Now, let's use something else other than unwrap. Let's use a match pattern. So listener awaits, and we're going to use this listener here as a match pattern, and we're going to check on that listener. Is it okay? Or is there any error? That's what we're going to do here. Just to have a control on the code, to not get the application stop running because of that. We can print the error if you want to print the error, but not panic. So if it listens, okay, we go in the okay side of the match pattern, of the result somehow. We pass, after if it is okay, we're going to pass it to the Axum serve function, which accepts the TCP listener. Okay, so the listener here is a TCP listener, which has binded the address, which is waiting for incoming requests. Axum serve is going to be serving this TCP listener. So here we write OK, listens. So listens, it can be any explanatory, it can be any keyword that you can put in, something that talks to you. So here I just put listens. So is the listener listening? It listens, okay. So here after we will use another match pattern. Otherwise, if it doesn't listen, that means there's an error. So here we're going to catch the error. Okay. And we're just going to print the error. Colon, question mark. I'm just going to use that from now on. And we put the error. So let's do the OK side now. OK, it listens. It's good. Error. Let me just close those first. And after we're going to do the match pattern. Let me get rid of this. And now we're going to be matching again. Using the Axum serve. Because we can now pass this listener to Axum serve. As we have everything okay. Everything fine. We can go to the next step. On here, same. In this match, we're going to be getting that listens keyword. So the listens keywords, we're going to be putting it in here. So the Axum serves need this TCP listener and the function that is going to be calling, which are the roots. The roots means, for example, if you have a different path, the path users, the path application page, the path blog, the path any page that you have. And here we're going to be using also await. So now we pass in these listens into Axum serve, which has a function also as a second parameter, function parameter. We are waiting on that, and now we can go into the OK and error. So everything went well. If everything went well, so the OK side, we print the message. We print the incoming message. Okay. So OK in this side here. So it is a nested match in another match. That's my level of coding in Rust for the moment. I believe there's better ways to do that, but this talks to me fine, and my brain understands it, so it's fine. Message, print, and after here, in the error side, error, and we're going to print the error. So there might be errors in different steps. You can maybe put a sentence here telling you where the error is, but I'm just going to simplify it and just focus on the OK side. Match the listener with the TCP listener. It listens, we do the whole matching side, otherwise we print the error. If it listens, we pass it to Axum serve, and after we check if the message is okay, there's no error, we're going to print it, otherwise we return the error. So this won't change for the tutorial, just this function here needs to be defined. So we're going to define this function. Okay, I'm just going to write a little comment. We're going to make the router function TCP listener the router to get those routes, those pass routes. So slash something. So this is, I see it more like when I'm in Django, url.py. I have some view functions. In the url.py, I'm going to define those routes, and that's the router for me. And any view function that route is going to be actioning are going to be the internal routes that are going to be called and triggered upon a call on that path. So router is not async, just defining routes like you would do in Django. If you go in url.py, you don't write any async and wait. You just define those routes. That's what we're going to do here. So here you see router struct. Okay, and we're going to be using inside routing with the methods get, post, and so on. So that's how it works in Rust. Function router, which is going to be returning a struct router. So the router struct of this function is going to be returned, and Axum serve is going to be using it with the listener TCP listener. So here, like in Flask or Django, you create your routes. So now let's use router struct new. Just going to close this comment so we can see the code. Focus on that. And now you can be chaining some other function. So .root, and that's where we are going to define the function, the path that is going to be triggered and the function associated to that path. So here, the address path to reach this function, job, could be API endpoint serving information. As we are starting with a GET request, it can be just anyone calling that root is going to get a message. And the message is set by the app. It's a static message, for example. So here the root, after the address that you have written above, will be 127.0.0.1, which is the local host, on port 8001/message. Now we need the function associated to the root. So this is more like a function defined in a views.py in Django. Okay. So like a function defined in a views.py. But here in Axum, in Rust Axum, we're going to be just wrapping those functions into the HTTP method. So how to do? Let me get rid of this and just show you directly, as I told you. So the method here we're using is a get method, which is going to be triggering a function. We're going to be defining this function. I give it a name now. It's called helper function get message. Okay, so function to be defined. After, I'm going to define that function. So now we are in a helper function, which is called the router. The router has a root message, and the message has a get request. Accepts get requests and triggers the helper function get message. Now let's make the function executed by the root on this get request. So when pass is called, so this function needs to be async. Async helper function get message. Okay. Do I need an input parameter? No, but I'm going to just return a string, an str, static str. Hello Shibuya. So that's what is the Hello World of Creditizens channel from Manga Kisa. Okay. So let's make a recap. We got this message. This is going to be output. When this function is triggered through a get request. The get request coming from here, we have imported it from routing Axum. The router here, root accepts on message root. So we get the trigger and calling this message root. the router itself, Axum serve, is going to be using it and printing the message if everything is fine with the TCP listener. TCP listener, I just need to close those also, comments. Okay, the match on TCP listener, which is defined here with TokyoNet TCP listener, which has binded the address that we have defined here, which is the address of our endpoint. And Tokyo help us to run everything asynchronously. I'm just going to close those imports to not get any warning or error message. Just going to get warnings for that. It's going to be using it after. Now let's run our first cargo run, and it's going to be just compiling, installing, building everything. So all the dependencies that you have added to the cargo.toml, and if there's any error, it's going to be showing you the error. If everything is fine, it's going to be showing you the print message telling us where is the endpoint. Okay, nice, we got an error. That's what happens. Match axum.serve. This is in Python, but in Rust you don't do it like that. It's double colon, not a point. It's fine, at least I could find it very quickly. Compiler is pretty amazing. Rust compiler, I really liked it. And here we're going to be building the rest. And now we got a string serving at running address. I'm not going to be using the internet browser. I'll be using curl. Let's open another terminal. Let's zoom in, as most of the followers of the channel are above 35 years old. We need to zoom in a little bit. Curl http 127.0.0.1.8001 the port /message for the root, and we got our message. Hello Shibuya from Mangakisa. I can close this. So this is your first HTTP request. Let's install cargo watch. So cargo install cargo watch, so that we can just run the server, and it's going to be updating automatically. So when you change anything in the file, it's going to be compiling on the background and updating the code. So you don't need to stop the server, restart it at every change in the code. It will be doing it automatically. So cargo install cargo dash watch. I'm just waiting a bit. It's going to be quick. So normally if you follow along, you don't need me to fast forward this part, because you're going to get the same waiting time. And this one, the Z bus, is going to take a while. That's the only one taking a while, and after we're good. And cargo watch. So to be able to handle all those processes, it might be passing through everything that we have installed before, to know what is installed and be able to run our server. and automatically recompile. So there is a recompiling process done, but we won't feel it and see it. It's going to be seamlessly done. So during this time, you can press the button to subscribe if you're not subscribed, and to like the video. Now we're done with this Cargo Watch installation. How do we use it? Just let me check. Cargo Watch. Something is happening. I don't believe this is the way you use it, but I'll just tap that into the console just to see what's going to happen. I didn't know what's going to happen. Okay. A lot of checks. Dev profile. Okay, it's been just checking. Nothing special happened. But here, Cargo Watch help. Let's see the different options that we have. We have the watch to watch specific files or folders. L, rust log, B, capital B, backtrace, the I, ignore, capital E, the env vars, S for shell, X for an execution of a command. So this is our friend maybe, the X one. Notify, the Q for quiet, but I'm not going to use quiet. I want to see those terminal outputs. So if there's errors, it will be outputting the errors, and I want to see it and be able to have the compiler helping me to fix it. So Cargo Watch X run. Yeah, that's the one. Let's see if it does update. I'm gonna change the code. So I've run it, it works. Let's just add a little bit more to it to see if it's gonna take into consideration this change. Let me just add /n for the output to look nice. Yes, we got it. So that's good. And we see here how it recompile and run again, recompile, run again, recompile, run again, whenever we save the file with changes. That's pretty amazing. So now we're good. We got our development environment ready for updates and everything. I'm just gonna be using post requests now. And let's see how we make those post requests. Before that, we need to uncomment the Axum routing posts, the response into response, because we need some structured response and to have the flexibility to so that's why I'm also using Serde into response, JSON, and the flexibility to render any kind of type. Just wrap it around the JSON, and Serde is gonna be our friend for that. And for the structs, so we still have our this side of the code won't change. The server is running. We just need now to add some route to the router. So we're gonna go to the router. Okay, we get one route called message. Is accepting GET requests. So let's see the first way of doing that. Having one single route accepting several different methods. So how to do a post request. So we will see two ways of doing that. Okay. So one way would be what we're going to see here first. post request from the same route as the GET request. So here we have a GET request in the message pass route. Okay, and here we're going to be adding a post request. So the message route now is going to be able to accept GET and post requests. So here we have our GET with our helper function, and we're going to be need to chain another one with a dot post. In this chain of functions, get, post, and inside the post, you are just going to define a function. Give it a name now, and we're going to go to define this function. That's very important that you follow all the steps. You can't jump into another part of the video, otherwise you're not going to understand. So post message handler. So we will need to make this function. Okay, the same as we did before. We're going to make this function. Let me close those comments so it looks clear. Okay, let's copy this and go define this function. This function is also an async function. Post message handler. We want to have the possibility to manage different types. Let me write it like that. So we will use post request method. That's what we used in the method. That's why we're using the post request method, and implement into response, the one that we the struct that we have imported from Axum. Okay. Just a reminder, all the handlers functions called by get, post, by any method. So all those functions that you're going to be defining for those HTTP methods have, put in capital letter, have to be asynchronous. Okay, otherwise not going to work. So now let's keep going, because here we're going to be using an input parameter. So we're going to add input parameters to those functions whenever we use a post request, because the user on the other side is posting to our API endpoint some data, and we want to be able to handle that data. Okay. In the function that would need deserialization. While the rendered response for some types or some structs that we're gonna make might need some serialization. Okay. So before sending this answer, we serialize, we send it to the user back to him, and when we receive from the user, we check if it is matching our structs by deserializing the user payload, the posted payload by the user. So this is going to return an into response or input parameter. Let's add it. Let's close those comments. There's too many comments. Let me close that. So that's the way it goes into my brain. I do it several times. I handle errors. I come back to you with a video. I comment it out. And after it's in my brain. So JSON payload. So the payload sent by the user is going to be wrapped in JSON. And it's of type JSON message post sent. Message post sent is a struct that I'm going to define. Okay. So the type is a JSON or custom struct. So I want the payload to be matching the message post sent structure. And that's what we're going to be defining. I don't know if I'm going to do the inside of the function first or the struct, but I think it's better to do the struct first. Let's do the struct first. So the message post sent, so that you understand why we need that. So API endpoint is accepting payload. Otherwise, it's going to return an error to the user. The payload has to be a message, a string message. That's what it's accepting. We're going to do a simple one for this one. On the next one, I'm going to show you another way to do post requests. And we're going to be using something more structured. So this will be the payload structure, sent message. We will need deserialize. For that, deserialize. Okay, from Serde. It's like getting the message from the user, breaking it down and checking if it matches the pattern of this structure that we want. Doesn't match, error. If it matches, we keep going in the logic, the structure, okay, of what you received. If you have to accept to receive or to send eventually. So here the code we're doing is more to understand how it works. It's not perfect code. There's a lot of edge cases which are not going to be handled, but you will get at least the structure of everything, how it works, and be able to start from here. Need to start at one point. So we need the decorator from Serde here to do this deserialization. So derive. So remember the feature that we have installed with Serde was derive, and in the derive there is deserialize now available. So we will be posting from outside to our API endpoint. Therefore, we just need to deserialize. Okay, so for this example, I just use deserialize, but normally here you would see deserialize, comma, serialize. You would see both. Okay, so we got a structure that we want. We want the structure message post sent when we deserialize it to match a message string. Okay, wrap it in a JSON. Here it's a JSON, it's wrapping the payload, which should be a message post sent. So same structure. So now you understand that payloads have to match the struct. Okay. Let me close those comments. And now we can do the logic of the function. Very simple logic. So we want to render. I'm just going to choose the type. So here, because we have into response, we can return any type. I'm going to show you that by returning a tuple. For example, so the second element of the tuple will be implementing into response. I forgot a keyword here in the function. I'm going to add it after, because I wrote that the function is returning an into response. It's returning an implement into response. Okay, so anything that is going to be returned, it's going to implement into response. And here I put into response. That's good. And this shows me that I forgot to add an import. Because what do we want to render when we do HTTP requests? We need the status code to be rendered. 200, 400, and so on. So we could have enhanced our error messages like that. Here I'm just gonna do a normal status code return, like created. Everything is okay. But I'm not sure that we're going to be able to see it even, because I'm using curl to call the endpoint. So everything is very raw. We won't get that returned. Or maybe I need to add an option. But I just want you to see how the code looks, at least. Or you can use Postman if you want. So let me put here this comment, and here I'm going to put the import, which is called, so from Axum. Axum, inside there is an HTTP, and HTTP has the struct status code. Let's go back to our returned tuple. So the first element is going to be the status code. Okay, so first element will be status code, and the second element will be the message. So the user is sending us a message, and we're returning this message back to the user. That's our post request. Accept only pair tuples. Oh yes. So I've tried to have a tuple returning more than 2 elements. And I learned that into response accept only pair tuples, not more. So we're going to use a simple pair tuple. First and second element. So let's put here this. That's our tuple. The first element is our status code, which is created, as we said. Okay. So it will work fine, but won't see it as I use curl, because I'm gonna be using just a simple curl commands, typical ones, and we won't be able to see that, but we will be able to see the message which implements into response. The payload is of type message post sent. That's why we do dot message, because we want the message from it. Okay. So we're playing with JSON here. So dictionaries like payloads. Okay. Message is a string. Payload message, which is a message post sent matching pattern. Okay, let's put it, we're gonna wrap it into a format, because I'm just returning the message here. Let's add a little bit more. Post request successful. The crossing is cleared. /n, and we're gonna put the payload message. Put a little comma. Okay, so let's recap here. Message post sent has a message in, has a structure that we want. It's a string. We deserialize what is incoming, and we check if it is the same. We return a tuple to the user on success with a message that we have formatted here and the status code. It implements response for the payload.message, I mean the format one, and we wrap into a JSON the payload, which has to be of type JSON message post sent. Okay, deserialization. Into response is going to help us because it's implemented to the function to render this. So this is all Axum structs. So they're part of Axum because we have installed it. And after here, the post message handler, which is the one that we have chained here into the post request. It's going to be triggered on post request to the root message, and whatever is in the top is always the same, it won't change. So you see the compiler now is showing me an error because now the server is running, and every time I change the code and I save the file, I will be able to see those errors directly into the compiler. So let's go back in. Here we can see what does it say. Yeah, I did an import, but we need a comma here, otherwise you can get troubles. After that, we still get an error here, not for the same reason. It's good that you see those errors. Can you spot it? So here it says unused, warning, serialize is not used. I know. And here there's a little error here because I put an escape. So I'm just going to get rid of it. Let's get rid of it. Okay, now payload message will be able to be loaded, and now we have our address. So it's running again. Cool. It's good to not have to restart the server every time. Let's do a curl to the get root that we've done initially, just to see if we haven't break anything by doing this chaining. By adding .post, we just check if it still works. Message accept gets request as before, all good. And now we're going to be formatting this post request that we want to do. So we do the post request curl, and after we're going to be chaining all those different options. Post, so we use the X option, capital X, post, and we put the endpoint, which was http://127.0.0.1:8001 for the port, /message for the path route. And after that we have the header -h, put between quotes content type application/JSON. So the type we're sending is a JSON. So the data is going to be formatted as a JSON, single quotes, curly braces with the keys and values. The key that our struct is expecting is a message. And after here, I can just put any message in. I'll put me. Cool. I can now cross safely. Thanks. And I close the message. Okay. So we got a message in a JSON to the root message, posting as a method, and here we got our returned value. Post request successful, the crossing is clear. Cool, I can now cross safely. Hope that you like this first part. Second part will be more exciting. Please like and subscribe. And let's go again into our main.rs. So that was the first way of doing your post request. Just let me comment. Just gonna do this like that. Just comment this out. So how to do a post request? We'll see two ways. The first way was by doing this chaining process, adding the post here that you see. So this is the first way. Okay, so from the same route, having some posts triggered on post requests. Okay, so this function is done, and now I can go here just to show the second way. will be creating another route path. So we've seen how to have a get and post in the same route, but how to add another route, another path for another code logic to make post requests or any logic there. So now let's do that. You just put a dot route. You repeat what you've done before. You add another route. Just think at your Django project, you're on url.py, you're just going to add a path. And here we do the same. The path here is called route. And inside we're going to write as first argument the path, as second argument the method that the HTTP request is using. It can be get or post or any other method that Axum accepts. And the function that is going to be triggered here, we're going to call it post message JSON handler. You can give it a cool name other than that one, but I'm just going to use this name here, and we're going to do the same. Now you get it. You make the function, give it some input parameters, give it a type of output. And after you do the code logic, you make a struct on the side or several structs for your input parameters to bind those to those structs to make sure that when you do the deserialization, they are matching. And when you do the serialization, you can make a struct also for your returned message to match it. So here we are going to do same, use structs. So if you got something running for the first part of the video, now would be more fun. But make sure that the first part of the video that you got your code running and it works perfectly, otherwise here it won't work. Because we are increasing here a little bit the complexity by adding the serialization of the output using struct also. This will show you also the flexibility and how you can structure your APIs, input and output accepted patterns. So here I'm just going to put it like that, serialize what we should output. That's how I see it. Any contradictory views, you can put just write a comment. A comment that helps the community to learn more. As I've seen that part of the people watching the video, there are a lot of experienced people. It could be that you're starting working with any IT stuff late, like me, or that you are an expert and could help us. So please comment. Control structure of come in and goes out, comes in and goes out, or error. Okay, so all the error handling will be handled by the top part of the code when we did our matching patterns. But for sure, at this level also, you can have some error handling. As I told you, the code is not perfect, but it shows you the structure of how it works. That's what we are targeting as a goal here. Input parameter need to match the structure tsutaya. We're going to have a structure called tsutaya. So JSON payload as in the previous function, and here JSON or custom struct, which is going to be called tsutaya. we stay focused on Japan. It's very important. Implement into response for the returned value of this function. The function is an async function. And we are going to make, same as we did before, let's make our struct. Okay. And then finish our function logic. So we're going to do the struct first, and after we're going to be going back into that function triggered by the post request. So here we're going to be using both serialize and deserialize for the decorator of the struct. So the struct is called Tsutaya. And the different fields of the struct are going to be affluence, which is a U64, a location, which is a string, a day in the week, which is also a string, and we check if Starbucks is present, if you have any Starbucks coffee or not. And after we have here, I'm just going to use serialize and deserialize. For this one here, I'm going to make another struct, which is for the response. So here, this struct is for both. What is incoming and implementing this Tsutaya. Serialize and deserialize, because we will receive and send it in the output. Okay? You will understand when you will see how I do the second struct here. Same here. Let's just use serialize. Derive serialize struct Tsutaya. I follow my logic in how I understand it. So this is going to be just the response. That's why I just use serialize. Struct Tsutaya response. That's the name. Receive data. We know that the payload coming is a Tsutaya type. So the receive data, we expect it to be Tsutaya. Extra info, we're going to be sending extra information as a response. So the received data is going to be rendered to the user, extra information, and Tsutaya from API. I'm going to send another message, which is of type Tsutaya also. So this is the schema of our response. Just mixing those types, so you can see that we can receive the type and we can also send it back to the user using the same struct. That's why we put on the top of that struct serialize and deserialize. Okay? So Tsutaya. Here, typos. You'll see some typos. You might be frustrated because you can't talk to me. And you have to wait until the time in the video I'll be fixing those. But you might have your own typos, right? So just pause the video at that moment, fix your errors, and keep going. So this is the schema of our response. It is an example. Okay, so you just play with it. And you add your own examples, different ways of doing it, whatever talks to you. Or just play with it. Let's close that. We got our structs, one for the output, tsutaya response, and another struct that we have defined, which is called tsutaya, for the payload incoming and for any also extra message that we want to send. And now let's define the two variables that we are going to send as a response. So part of what we send back to the user is going to be two custom variables. One is a string and the other one is of type tsutaya, which is the struct that we have defined. And we are also going to return to the user his own message that he has sent us. Okay. And the deserialization for the incoming parameter. Let's go. Let's start doing that. We're going to call this one extra info. And then we're going to be wrapping it in a string, an str in a string here, and we write our str. Let's put it like that so we can see everything in the screen. I am a Garo from the API. Okay. It's not very interesting information, but it's okay. If you understand the structure, it's fine. Let tsutaya from API, and here we're going to be building our tsutaya. That's what we want to render. Also, we're going to create here just a custom tsutaya. Affluence 357. Location was a string, so we're going to wrap it in a string here, the str. And we're going to call it's a Shibuya. The day in the week, let's say it's a Monday. And Starbucks present was Boolean, so true or false. We just go true. There is a Starbucks there. Not a place to study or work, just to watch people crossing. Let's close this. Close those comments. Okay, we got our two variables that we want to render. And this is the struct that we have used to make the tsutaya one here. It's matching. Affluence, U64. Those are strings, location and day. And so represent is a Boolean. Good. Extra information is a string, which is here. Extra info is a string. And tsutaya from API, that's the one that you have defined. And now the received message also will be a tsutaya, a JSON tsutaya, the payloads. So how are we going to do that? Now we get the response, get the incoming post request. Okay, the incoming posted message to the endpoints. So user is sending us a message. We're going to define our response data, which is of type tsutaya response. That's what we have defined. And here we're going to be building it the same way that you have built the Sutaya struct, using the fields and putting in each field the right data. Received data is of type payload, because it has to be of type Sutaya. So the payload will be of type Sutaya. The extra info here will be just the extra info. And this one here, Sutaya from API. Okay. I put receive data that way so that you understand what's going on. Those ones here has to be a string, and the other one is Sutaya. Okay. Which is of type Sutaya also. And it's good. Everything is prepared. Extra information. What we render to the user. And now we have implemented into response. Implemented into response. So we can do our response. Should we do just the same tuple as we've done before? We added a bit of complexity, but we can see how into response helps us to render anything. So let's use a tuple again to simulate the API response. So we're simulating API response with the status code and the response. So status code, not going to change, created. Okay, comma, and here, response data. We wrap it in a JSON. JSON from Axum. And we put our response data in. So the response data, you see, can be anything. Here it's a custom struct. Wrap it in a JSON, and it's going to be rendered as a JSON. Okay, and this is going to be implementing into response. This is going to be helping us. So I think we are all set here. We got our Sutaya response. It's going to be serialized to send it to the user with the received data that we're going to send back to the user, and 2 extra fields, 1 string, another one of type Sutaya, serialized and sent, and deserialized when the user sends it to us, affluence, location, day, Starbucks present or not. So the user needs to build that. We return a tuple, okay, with the response and the status code. Sutaya response with those fields. Status code is going to be rendered. Okay. Extra info. Those are the information coming from our API that we send it back to the user. You can put it here any code logic, functions, and so on. Into response is implemented. So it's going to be able to render this tuple. So the payload is wrapped in a JSON. And the JSON, we expect that payload to be of type Sutaya, matching that struct. Serialize, deserialize. And after, we can go take this function. There is a little typo here. Okay, it's async. Okay, you've been frustrated. You've seen that maybe from the beginning, but it's fixed now. And now let's go back up to the root that you have created. So that function is going to be called by the post method of the root to this path whenever called, structured output. Okay, and whatever is in the top, we still get our message root. We keep it. Whatever is in the top won't change. We might do we need to look at the compiler if there's no error, or shall I curl directly? Let's do a get request to see at least if what we've done before still works. It is not fake. What was message? Refused. Let's go and see. Compiler tells me there is an error somewhere. Starbucks present, and here I say Starbucks present, so there is a S. So you better just go to the compiler first before running anything. And let's, I'm gonna add the S to the struct. So let's go in the struct and add the little S. Update, cargo watch. I've done the recompiling job. It's done. You've seen it live. Server is running. Let's do the message. The get request works fine. Let's call structured output in a get request to see what's going to happen. You see nothing happened because we didn't define any get, but we might need to handle that in a different way. By outputting an error message or something like that, but this is the curl message. So curl x post, we post into the endpoint structured output. The header is a content type application JSON, and here for the data sent, we send to JSON, so single quotes around those curly braces, and inside we put the key value pairs. The affluence is 500. The location is Azerbaijan, and what was it? The day is Sunday, and the Starbucks presents was a boolean. You're gonna just say true. So we need to wrap it or not. True, just like that. So we have everything set. We send it. What do we get back? Doesn't look right like that, but still receive data that we have sent. So this is the plan. We have sent back that data, like a recap, extra info. I'm a Garo from the API, Tsutaya from API, say the affluence is 257, and Shibuya on Monday. And there's a Starbucks. Cool. So I'm just gonna do an extra request just to show you that the code is not perfect. You need to handle more cases, but at least you've seen how to do post, get requests, different routes, and so on. So let me here do something funny. Here, so this is an error, for example. You see, there is no S, so the error is triggered. We get an error from the Axum serve, the match patterns. But here I'm just gonna do something like that. I'm gonna add a field. I'm gonna send one more field. Count friends present. So there is, it says there is 30 friends present. It still works. So if there is extra field, it shouldn't work. You have to make it so that it shouldn't work. But still, it should work. So the code needs improvements, but you've seen how to do those calls, how it matches a little bit Django. Please like and subscribe. I'm going to come back to this example just to show the behavior of Serde serialization and deserialization, the parsing, which is lazy, so that's why we get that. So here I'm just gonna curl it again. I'm gonna show those examples from the beginning to do this new section of the video. I'm just gonna change first to the root. Just get rid of the underscore, put it like that. Structured output, okay. It has automatically recompiled. We're gonna make just a get request to structured output. So as you can see here, nothing happens. This is the laziness of it. I'm gonna create a get root, and for the other one that we did before was the post requests. So here we're gonna just do a new one with some new fields. So if you're following along, just tap or just reuse what you just used before, and you just change the data that you send, so the different fields of the dictionary. Here this is not going to change, only the structured output. Now it's not an underscore, it's a normal dash between structured and output. The header is a content type application JSON, and we are just going to send some different data this time. Just let me put it between single quotes, and inside we use the double quotes. So we have the affluence, which is busy. It's gonna be 1097. After we have the location, we're gonna go in another neighbor, which is Omote Sando. Let's put a space maybe. Yes. And after we're gonna go for the day. Today will be Saturday maybe. Let's put Saturday. And Starbucks presents. We've been putting true. I'm gonna put just false here for this one. So let's go false. Okay, so this I send it. I received a recap of the data that I've sent, a sentence, and the custom struct that we have built in, and instantiated through a variable. After I'm gonna add again an extra field. So adding an extra field, we've seen what happened. So count friends present, that's the new field that I'm gonna add, and send it. 28, I send it, I don't get any error message. It's just rendered the fields that he knows. But we don't want this behavior, we want it to return an error. And there is a nice way to do that. So first, let's go to the root, structured output, and add our get request. So now you know how to do the chaining, dot get. I'm gonna call it friendly, maybe utopic message. So this is gonna be an easy function that we're gonna do, and just send the message back. Okay. So you handle that the way you want. You can return an error if you want. But the get request is just gonna return a normal message. There's no reason to return an error for that. So we're gonna implement into response as we did before. We use the str. We're just gonna return the str, no war, peace, and love. Pretty utopic, right? In the world in which we live at the moment. And after here, we're going to go to this struct. So we have derive, serialize, deserialize, but we still get it to work even if we add some extra fields. So let's comment a bit on top of that. So the Serde parsing is lazy. To put you in a scenario, imagine that you are calling an API, an LLM. You're getting a response from it, but you just need some specific fields. So here you don't need to do anything. The fields that you're going to capture from that output, from that response, will be those defined in the struct that you have defined in your code. So that's nice, that's what we want. But let's say you're the one providing the service and you want to have it more strict. So here we are going to make it strict. So here you use struct to catch those fields and its behavior. So the normal behavior is to ignore the other fields if there are some extra fields, like we did before. You've seen that it has ignored those fields. For example, here when you call an LLM, you can maybe ignore the metrics because you don't want to know about the metrics. You just need to play with the messages. Here we are going to make it strict so it doesn't ignore any fields but return an error. Okay, so more strict. I'm going to close all those comments. Now you understand what we're going to do. And I'm going to add this decorator, which is Serde. And using deny unknown fields. It's very explanatory. It's pretty nice, right? That they call it like that. More strict equal using the decorator deny unknown fields. Okay, so now we got it. Let's go back to the terminal. We clear this. Let me make this call. Now we get our message. We have implemented this get route very quickly. Let's make the normal call. Count friends that we have added. Count friends present unknown field. So we get an error message. Count friends present expected some other fields. Affluence, location, day, Starbucks present. So let me try to change it. And just let me do this like that. I'm going to clear this, call it again. Let's use a duplicate field. Attendance, the affluence, that's what we had. Yes, affluence, and I put, I don't know, 7. 1, 2, 3. Failed to deserialize the JSON body. Duplicate field affluence. Okay, so this is a bit more strict. That's how you would handle that. Okay, we have seen how to make API calls like in Python using routes and functions associated to those routes, more like in Django. Here in Rust, one route can have chained get and post requests, or we can create another path route for other code logic endpoints. We have seen that Serde is a great help to serialize and deserialize the requests sent or received, and that we need to define structs to accompany that. But you need to have a code a little bit, as I would say, handling those edge cases in order to be able to have a real running production API. We have seen Tokyo, which is needed as well to be able to make those functions asynchronous and to accept also those TCP listeners. And it is like in Python. In Rust we use async await, so you don't feel lost for that. Let's keep going with Rust. I'm happy with Pio 3 and Maturing. They are pretty amazing to use. I'm using it in a Django AI project at the moment, but there is a lot of work and unit testing that I don't like to do. Let's stop here. Hope that you liked this video. Please like and subscribe, and see you next time.